Today's lesson is on solving one and then two-step equations by balancing. We spoke about this a little bit last week about how if you do one thing to one side of an equation, you have to do the same thing to another. So a good way to visualize that is to think about the equation as a set of scales or a seesaw. So imagine that they're perfectly balanced. And here we have the equation x plus 2 equals 5 represented in this way. So on the left-hand side of our equation, we have x plus 2. And on the left-hand side of our scale, we have this green block, which represents the x, and then two little 1 blocks, which represent the 2. On the right-hand side, we have 5. And on the right-hand side of our scale here, we have 5 little blocks. So that's how we can represent this equation here, x plus 2 equals 5, visually or on a scale form, because you can see that they are balanced, okay, that the scales are equal. And that's all an equation is. It tells us that what's on the left-hand side is the exact same as what's on the right-hand side. And then we have to work a little bit to find the value of the letters that we don't know the value of yet. And ultimately, our goal here, and our goal when solving any equation, is to get the unknown letter on its own. We want to work out the value of that letter. So in this case, we want to whittle down to get x equals a number. And that's the same for any equation, whether it's in terms of x or any other letter. So what we want to do is think about what is stopping the x from being on its own. And before, on the previous slide, what was stopping it from being on its own were those two blocks. And you would think, well, okay, it's really easy. What I'll do is I'll just take those two blocks away. But you can see over here that when you take the two blocks away and they're not on top of this x anymore, now our scale's totally out of balance. So this side is too heavy and this side is away up in the air. And I always like to think about using the equal sign as being a privilege. You're not entitled to use the equal sign. And if you start doing things to one side that you don't then balance out on the other, you don't have the right to use the equal sign anymore, which means it's no longer an equation. You've now got an inequality. So because we've removed 2 from the left-hand side and our scales are now out of balance, we have to take 2 away from the right-hand side as well. So here I can just score out 2. And then you can see down at the bottom that we still have the x on the left, but on the right hand side now, we only have 3 because we had 5, but now we've gotten rid of 2. And now our scales are balanced again, which is what we were looking for. And we have x on the left hand side and 3 on the right hand side. And now we just need to think about how we can write that formally and mathematically, because if you're doing a test or a homework or classwork, you're not going to draw out this elaborate set of scales or a seesaw. So we're going to think about how we can write that and show our working to show all the steps that we're doing. So our original equation was x plus 2 is equal to 5. And what we did is we took 2 away from the left hand side and we also took 2 away from the right hand side. If you have x plus 2 and then you take away 2, you're just left with x on its own. And if you have 5 and you take away 2, you're left with 3. And that is how you would write that algebraically. The second example, we're being asked to solve the equation x plus 4 equals 9. And again, it's been represented here as a scale. So on the left-hand side of our equation, we have x plus 4. And that's represented by the green x block and then the 4 little individual blocks here. And then we have 9 on the right hand side, and that's what's represented over here. So our goal when we're being asked to solve is to get x on its own. And we have to look at this and think, well, right now, what is stopping x from being on its own? And what's stopping it is the 4 that's on the left hand side. So we get rid of them. But if we've gotten rid of 4 on the left-hand side, we also have to get rid of 4 on the right-hand side. So we'll get rid of 1, 2, 3, 4, and then we can see what we're left with on the right. So on the left-hand side, we just have x, which is what we're after, and on the right-hand side, we have 1, 2, 3, 4, 5. So we know that x is equal to 5 blocks, or equal to 5. And if you're wanting to check this answer, what you can do is you can substitute it back into your original equation. So you can say, well, if I'm trying to say that x is 5, then 5 plus 4 has to be equal to 9, which it is. So you know that you've done it right. And now writing that out mathematically and algebraically, we started with x plus 4 equals 9. We took 4 away from the left-hand side, which meant we also had to take 4 away from the right-hand side, which left us with x on the left and 5 on the right. Okay, now that we've done a couple of these and you've done some practice in the booklet, we're going to step away from using the scale diagrams. And it's fine if you want to keep visualising that in your head, but what we want to get into the habit of doing when we're showing our working for these questions is laying them out like this. For this third example, I want you just to pause the video for a wee second and see if you can notice what is different about this one compared to the other equations that we've looked at. So you might have spotted that the difference with this equation is that instead of having a plus sign in between the x and the number on the left-hand side, we have a minus sign, which means that we aren't in a position here to just take 2 away from both sides, because on the left-hand side, we don't have 2 to take away. So if we're trying to balance that out, we're thinking about how do you undo taking away 2? And the way to do that is to just do the opposite of taking away, which is adding. So here, instead of taking away 2 from both sides, we're going to add 2 to both sides. So on the left-hand side, the negative 2, so our minus 2 and the plus 2 cancel each other out and they just go to 0. So we're left with x equals, and then 5 plus 2 is 7. And if you want to check that, what you can do is you can go back to your original question and say if you're trying to give an answer of x equals 7, then 7 take away 2 has to be equal to what's on your right hand side, which is 5. And you can check that really, really quickly. If you're getting a wrong answer, if for example you ended up with x equals 3 because you'd taken away 2 instead, then you can go back and fix it, because you would be saying, well, 3 take away 2 is 1, which isn't your right hand side. Your right hand side is 5. So if you're looking for a general rule here, it's that you're going to do the opposite of the operation that is on the left hand side. So if you have x plus 9, you would subtract 9 from both sides. If you had an x minus 3, you would add 3 to both sides. So it's about doing the opposite, and we know that the opposite of addition is subtraction, so the opposite of subtraction is addition. So you're doing the opposite operation to balance your scale.